Hello students. So today we are going to do some physics numericals. Okay, and this numerical is from ray optics. This is lens maker's formula. Okay, where we take the convex lens. Okay, and focal length 1 upon f is equal to, this is refractive index mu minus 1 upon r1 minus 1 upon r2. So radius of curvature. Now focal length. Okay, this lens maker's formula is also applicable for concave lens. So when you take a concave lens, focal length is negative. Okay, and when you take convex, it is positive. Similarly, for radius of curvature, for convex, R1 you have to take positive and R2 negative. For concave, you have to take R1 negative, R2 positive. Okay, let's solve an example. Double convex lenses are to be manufactured from a glass of refractive index 1.55 with both faces of the same radius of curvature. Okay, what is the radius of curvature required if the focal length of the lens is to be 20 centimeter? Okay, so first you have to write what is given. So double convex lens. So convex lens is given and refractive index is given to be 1.55. Okay, with both faces of the same radius of curvature. So radius are same, that is R1 and R2 are same. Okay, for convex we take R1 positive, that is this will be R, and for, okay, I'll write here plus R. Okay, and for R2 we take it as negative. Okay, and then they have given what is the radius of curvature required if the focal length of the lens is to be 20 centimeter. So f is given to be 20 centimeter and it is positive. Okay, for convex you have to take it as positive. Now you have to find out value of r. Okay, use lens maker's formula. So this is 1 upon f is equal to mu minus 1 upon r1 minus 1 upon r2. Okay, so 1 upon 20 is equal to 1.55 minus 1, r1 is r, this is 1 upon minus r. Okay, so this will be plus r. This is going to be 1.55 minus 1 is 0.55. Okay, so this is 1 upon r plus 1 upon r, which is 2 upon r. Okay, so you can take this r this side and 20 this side. So it will be r equal to into 2 into 20. Okay, now you have to multiply. So this is 2 to the 4, 40 into 0.55, 22. Okay, 22 centimeter. Second question, the radius of curvature of either face of a convex lens is equal to its focal length. What is the refractive index of its material? Okay, so radius of curvature of either face of a convex lens. What is given? Convex lens. So you have to take R1 positive, R2 negative. Okay, and they have given it is equal to, that is radius is equal to its focal length. Both are same but they are equal to focal length. So this will be plus f, this is minus f. Okay, what is the refractive index of the material? So you have to find refractive index. Okay, so using the formula lens makers 1 upon R2, this is F, positive F, and this is negative F. Okay, so this is 1 upon F plus 1 upon F, that is 2 upon F. Okay, you can take this side, so it will be 1 upon F into 2. Okay, so this is mu equal to 1 going that side, so this is positive plus 1. Okay, so cross multiplying you will get 3 by 2, and 3 by 2 is 1.5. Okay, so refractive index is 1.5. Let's solve next question. A convex lens of focal length 0.2 meter and made of glass mu equal to 1.5, this is refractive index, is immersed in water. Okay, and refractive index is given 1.33. Find the change in focal length of the lens. Okay. So you have to find how much the focal length has changed. Okay, so whatever is given, first you write that. So convex lens it is. Okay, focal length is given in this is immersed in water. Okay, so with respect to air it is given. So focal length in air meter, then refractive index of glass with respect to air is given, which is 1.50. Okay, and F of water we have to find, where glass with respect to air. This is immersed in water with respect to air, it is given 1.33. Okay, so we can use the formula, lens maker's formula, 1 upon F. So air we are using into 1 upon R1 minus 1 upon R2. Okay, so this is given to be 0.2. This is our 1.5. Okay, so this is 0.5. So 1 upon R1 minus 1 upon R2 is 1 upon 0.2 into 0.5. Right? So this is 100 upon 10. Okay, this is 10. So 1 upon R1 minus 1 upon R2 is there, that we can use to find focal length in water. Okay, but here they have given refractive index of is that? Is immersed in water. Okay. Glass. So we want this refractive index of glass with respect to water first. Glass with respect to water. Okay. That we can find by using refractive index of glass with respect to air upon refractive index of water with respect to air. Okay. So this will be 1.50 upon 1.33. So this we have to use here when we are finding focal length in water. Okay. So this is glass with respect to water, R2. This is 1.50 upon 1.33 minus 1, and this we have got 10. Okay, this you have to cross multiply. So that I'll do here. Point we can eliminate because both are 0.50 means 2 decimal places, 2 decimal. So point we can eliminate. So 150 upon 133. Cross multiplying. Okay. So 17 upon 133 into 10. 17 into 10. So this is 170 upon 133. Okay. So FW is 133 upon 170. This you have to do this thing. This is 133, 170. Dividing, you'll get the answer. 0.7. The answer is 0.7. Okay, this is the focal length. So we have got focal length in air, we have that is 0.2, and this is focal length in water. So change we have to find. Change is 0.7 minus 0.2, that is 0.5. Okay. So next question, a double convex lens has radii 20 cm. The refractive index of glass is 1.5. Compute the focal length of this lens in air and when immersed in carbon disulfide of refractive index 1.63. So this is almost similar to the last question. Okay. So let's write what is given. Okay. Convex lens. Radii is given to be 20 centimeters. So R1 is plus 20 and R2 is minus 20. Okay. Then the refractive index of glass is given with respect to air. 1.5. Compute the focal length of this lens in air. Okay. So first you have to find focal length in air. Then when immersed in carbon disulfide. Okay. Then also in carbon disulfide you have to find. Okay. And the refractive index of 1.63 is given, that is the refractive index of carbon disulfide in air, right? With respect to air it is given. Okay. So first we'll find focal length in air. R1 minus 1 upon R2. This is 1.5 minus 1, 120. So minus of minus 20, so plus 20. Okay. So this is 0.5 upon 10. So we can write it as 10 upon 0.5. So removing the point, you will get 100 upon 5. Answer is 20. Focal length is 20 centimeter. Okay. Next, we have to find in carbon disulfide focal length. Okay. So first, you have to compute see, f upon 1 upon f of c, that is carbon disulfide. You have to take the refractive index of glass with respect to carbon disulfide. Okay. This we have to compute by using refractive index of glass with respect to air upon refractive index of carbon disulfide with respect to air. This is again, it will be 2 upon 20, right? This is 1.5 upon 1.63 into 1 upon 10. Okay. Cross multiplying, you will get so this is 50 minus 1.63, 0.87 upon 1.63 into 10. So these 2 points we can cancel. So it will be 87 upon 1630. Okay. Oh, sorry, I've done the ulta. This is negative. 1.63 minus 1.50 you have to do. 0.13 minus 0.13. Okay. These points I can remove. Minus. Okay. So this is minus 1630 upon 13. Then you have to do the division. One to 5.4 centimeter. minus. Okay.